Guys, I'm back with another low-tech video for you today. We're going to do something a little different than usual, a little off color for the topics I normally cover, but I'm just all about putting knowledge on YouTube. So I figured I'd touch base on something that a lot of people seem to struggle with, or at least a lot of people I've ran into, and that's two's complement notation in computer science. So if you don't know what that is, there's no need for you to watch this video, but if you know about it and you just want to learn how to do it, I'm going to take a moment and show you. So, two's complement is a way of representing negative numbers in binary. So let's say we've got an 8-bit binary number. I don't know how to do this. Let's try like this. Okay. So 8 bits. Let's just draw 8 zeros here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Obviously, these are your 1s, your 2s, 4s, 8s, 16s, 32s, 64s, and 128s. Okay, these are your bases. So if I were to write something like 0, 0, 0, 1, 0, 1, 0, 0, this would be the number 20. Yay, that's not a factorial. Now, what if I wanted to write negative 20? How do I do that? Well, I'm not going to get too far into it, but your computer does it using two's complement. And what I want to touch on in this video is how to actually create a two's complement number using its regular binary form. Okay, sorry. Brief interlude there. So we're trying to turn this number, 20, into its negative as a computer would see it. Fortunately, outside of all the things they tell you in class about how to add certain, and they have all kinds of weird ways they want to show how to do this, and they do a really good job of illustrating why two's complement work, but they're not very convenient. I'm going to show you right now the most convenient way to do this. You find the least significant bit, which is just the smallest non-zero bit. In this case, it is the 1 here that represents a 4. You keep everything up to that bit, and you flip the rest. Really simple. So in this case, I would have 0, 0, 1, and then we start flipping. 1, 0, 1, 1, 1. That is the two's complement for negative 20. The great thing about two's complement is that math works the same way when you're adding and subtracting numbers in binary, whether they're in two's complement or not. So if you're familiar with how to do binary addition, say we wanted to add, let's say 24 plus negative 20. Now, so we'd have to write the number 24 in binary, okay, which would just be, now I'm going to have to add that up. Okay, duh, that was really easy to add. I paused you for a second there, but I didn't need to. It's just going to be 0, 0, 0, 1, 1, 0, 0, 0. So we've got our, basically, we're going to do 8 plus 16. And that's it. That's 24. And we wanted to add the negative 20 to that. Well, we already have our two's complement for negative 20. It's 1, 1, 1, 0, 1, 1, 0, 0. And we're just going to add this like we would add any two positive binary numbers with one little caveat. So let's add these up. You get 0 plus 0, 0, 0, 1. And now, here we're going to get a 0. Carry that, you get a 0. Carry that, you get a 0. Carry, 0. Carry, and 0. Now, normally you would want to carry and write a 1 right here over your imaginary 0. But when we add with two's complement, remember we're just working with 8-bit numbers here, we're going to ignore that. Doesn't happen. Okay? So now what do we get? You get 24 plus negative 20 equals Well, here are our 1s, here are our 2s, here are our 4s, equals positive 4. That's amazing. So that's just a brief little introduction to 2's complement, sort of its practical use, how to convert from a positive binary number to its negative version in 2's complement by flipping every bit after the least significant bit, which is just the smallest non-zero bit, and a demonstration that adding negative numbers using 2's complement is no different than adding positive numbers. Follow the same rules. This works also for subtraction. It's a great tool if you're struggling with how to do this in your Intro to Computer Science class. Hopefully that helps you. Thanks for watching.